All right, class, we got a little bit more difficult lecture in for today, IUPAC Nomenclature Part 2 and Chapter 11, Organic Chemistry of your textbook. So last class period, or last video, we talked about, the organic structures, how to write organic structures using the skeletal formula, the structural formula, the condensed structural formula, and we also talked about what alkyl groups are, that being an alkane, deleting one of the hydrogens and connecting it to a larger chain. And there are specific types of alkyl groups, such as the methyl group, ethyl group, propyl, isopropyl, and butyl group, which we went over. And then I gave you an introduction to IUPAC nomenclature, noting that this particular one that I went over, 2-methyl-2-ethylhexane, though I was trying to draw a point, that is an incorrect structure. And after today, you're going to be able to clearly see why that was incorrect, okay? And so, and I talked about why it's incorrect a little bit at the end of last video, but it may have seemed a little confusing. So after today, I think the clarity will come. So make sure you practice this. Make sure you understand what all your prefixes are, and then we can get started. Okay, so all these are drawn in the skeletal or the line angle formula. So if you are not skilled at reading these, you may want to practice. Okay, so the first thing we're going to do, and we'll call this number 1, we're going to find the longest linear chain according to our rules. Now you can go 1, 2, 3, 4, 5. Or you could have gone 1, 2, 3, 4, 5 to get the same exact thing. So we'll just delete some of them. And I'm just going to go through the way you might be going through it. So you just numbered it 1 through 5, but don't stop there because there may be another way to number it. We just focus on the left to the right, but what about right to left? You could also go 1, 2, 3, 4, 5. Now that might show some payoff because what you may notice if you were to outline your molecule is that that's my longest linear chain, but there is this group stemming off of it right there. Now, based on my numbering, if I use the red numbering, it comes at carbon number 4. If I use the blue numbering, it comes at carbon number 2. Well, that is where this rule comes in. Number the chain in such a way to get your groups to be labeled at the lowest number possible. So if I use the blue way of numbering, the methyl group occurs at carbon number 2 versus carbon number 4 using the red way. So actually the blue way is the way to number this molecule properly. Okay. So the way I like to do these is I like to piece it together, then add the puzzle pieces together, okay? So what we have is a 5-carbon chain, which we will call a pentane. That's the 1 through 5 numbering, and we see at carbon 2 we have a methyl. So there'll be a 2-methyl. That is a CH3, by the way, right there. It's the end of a line. It's a methane without the 4 hydrogens. It only has 3. So that's all we need to consider. So let's put the name together, 2-methyl. There's no space right there, so I'm just going to put pentane as one word. And that's going to be the answer. Notice that between 2 and the methyl is a hyphen. And notice that the 2-methyl belongs in front of the root name of the molecule, which is pentane. Okay. Let's move on to example number 2. So hopefully now you can eyeball it and say it's going to have to be numbered right to left because you can hopefully see that those groups will be encountered earliest number possible when numbering in such a way. So 1, 2, 3, 4, 5. You could have numbered starting here or here and gotten the exact same thing because they're all the same exact group. You'll see what I mean. Had you numbered it using that way, you would get the exact same name no matter what. Okay, I noticed that there are those 2 groups stemming off the major longest linear chain right there. And that's all we have to consider. So let's look at this. So we have these 2 groups right here coming off of carbon 2. So it's going to be a 2, 2 because you have to account for both of those methyl groups. And then dimethyl. Okay, that's that prefix right there that is stated right here. If more than one of the same group is present, indicate it with a prefix. So 2 is di. And then you had to put 2, 2 because it's saying each of those methyls occurs at carbon 2. And then we have a pentane. That's a 5 right there. So let's put it together. 2, 2, dimethyl pentane. All right. You can try one of these 2. I'm going to move on to, this is 3. This is 4. You can try those on your own. Let's try number 5. Okay, now let's find the best numbering system. So I'm just going to eyeball it and say it's going to work best go in this direction. So we have another pentane. I guess I was in a, just enjoyed making pentanes that particular day that I made these structures. And you may notice that there is a methyl group stemming off of it. And so they occur at 2 and 3. And so we have a 2, 3 dimethyl. And we have a pentane, so add those together to get your final answer. And notice that had, like in example number 2, had I numbered 1, 2, 3, 4, 5, that would have been a 4,4 dimethyl, but 2, 2 wins, okay, because it's a lower number. In this most recent example, number 5, I could have numbered it 1, 2, 3, 4, 5. So that would have given me a 3, 4 dimethyl. Well, 2, 3 is lower than 3, 4. Okay, so that's how I knew to go that direction. And finally, you could go 1, 2, 3, 4, 5, 6. For example, number 6, 1, 2, 3, 4, 5, 6. But you're not going to get to that group in time. And so that method would actually be inferior to this method. But what if at 3 you went this way? 4, 5. Well, 5 is less than 6, so we're not going to do that. Okay. But there's one other way we might want to consider. So 6 is our winner. 1, 2, 3, 4, 5, 6. If you were to do that, you get 6 also. Okay. Well, if you number it the way I just did, you encounter 2 methyl groups at carbon 2. If you were to number it like this, you get this group at carbon 3. So actually the blue way is going to be better because you get a group at carbon 2 versus in the red way you get a group at carbon 3. So we're going to stick to the blue way. I'm going to outline our molecule right here. And hopefully you can tell that right here at carbon 2 is a carbon bound to 4 other carbons, okay? Just in reading line, angle, or skeletal formulas. So let's piece this together. What I am seeing is there at carbon 2, we have a couple of methyls, and then at carbon 3, we have an ethyl. So we have a 2, 2 dimethyl, and we have a 3-ethyl. Don't forget the rule about alphabetizing. And when you're alphabetizing, this is super important. If there's a di, you don't count that as a D. You just omit the prefix and you start with the M. And so what this molecule would be called is 3-ethyl for alphabetical order, -2, 2 dimethyl, and then hexane, because there's 6 carbons in my longest linear chain. So these are tough, y'all. Make sure you practice. I gave you some tough examples so that you can see how to work these out methodically, as I did, but just find the puzzle pieces and put them together. Here are the answers for you, by the way. So if ever you wanted to try that one or this one, those are your answers, okay? I can also ask you to draw the line angle formula from the name itself. I find this to be easier. So let's start with butane. Draw yourself a butane, and then let's number it 1, 2, 3, and 4, and then throw a methyl right there, and you are done. If you do 2-methyl-3 isopropyl octane, I'm going to draw me 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. And it wants a 2-methyl, so at 2 I draw, So at 2 I draw me a methyl, and at 3 I draw me an isopropyl group, okay? Which kind of looks like a V connected to the main chain using a line. 2, 2, 3, 3 tetramethylhexane. I would just draw me a hexane, and then that's carbon 2 and 3, 3. And then tetra indicates that there are 4 methyls, and then you can try the 2, 3, 4 trimethylheptane, but here's your answers right there. And then we can also do this for haloalkanes, and so whenever you deal with halogens, that would be called chloro group, because that's a chlorine atom attached to a major chain. And so the way you would name this is first find your longest linear chain as always, 1, 2, 3, 4, 5, or you can number it the other way, 1, 2, 3, 4, and 5. Now, I'm going to go ahead and tell you that the right to left method is the correct way, even though you can encounter groups at carbon 2, no matter which way you go. Chlorine on the periodic table has a higher atomic number than a carbon. Okay, so that's how you distinguish between those two. Chlorine wins the battle because it has a higher atomic number than carbon. Okay, and so now that we got our longest chain, let's outline that so that you can clearly see it, all the groups that are hanging off of it. So what I see is a 2, 2, 3 trichloro, and I see a 4, 4 dimethyl, and we have a pentane as the longest linear chain. So let's put this together. Alphabetically, chloro beats an M, so that's all that you do. 2, 2, 3 dash trichloro, excuse that, dash 4, 4 dash dimethyl pentane. For this one, the next one, don't get confused. You have a bromine at carbon 1. So that's just going to be, and you have a methyl off of carbon 3, so that's going to be a 1 bromo, 3 methyl butane. So sometimes that gets confusing whenever they're hanging off of carbon 1. It's easy to forget that you would start numbering there because you have a substituent or a group coming off of carbon 1. And then also a methyl off of carbon 3. And then this final one, 1, 2, 3, 4, 5, 6. So you encounter a methyl at 3 and a fluoro at 6, or at 5, versus numbering this direction, fluoro at 2, which is the better way. So that's going to be 2 fluoro dash 4 methyl hexane. Noting that methyl group is coming off and that fluoro is coming off right there. So we had to account for those. And I did this really fast. I realized that it's after years of practice, fluoro, and I also alphabetized. F is greater than M, B is greater than M in that example. So here's your answers right there. Make sure to spell fluoro correctly with the U-O-R-O. And there are cycloalkanes as well. You just have to add cyclo to the name. So cyclopentane has 5 carbons in a cyclic fashion. Cyclohexane looks just like a hexagon. Cyclobutane is going to be a square, noting that there's 1, 2, 3, and 4. So just add cyclo whenever they're attached in a ring. 1-methyl cyclopropane, you just have to add a methyl to that triangle right there because you have cyclopropane right there and a methyl coming off of it. You don't even have to really put the 1 because any position that it's on will be designated as 1. And then the 1,2-dibromocyclohexane is going to be 1,2-dibromo. I could have put them anywhere on the ring because wherever they wound up, I would have just made that 1 and 2. And so there are your answers. Next, we're going to get into naming the new functional group called alkenes. Keep practicing, email your instructor, look at plenty of examples. With enough practice, you'll find that you get really good at this. Have a wonderful day.